Hi, my name is Laura, and today we'll be answering why the skies are blue, the clouds white, and grass green. This presentation is relevant because it explains how the visible spectrum behaves with different particles such as chlorophyll and water droplets, answers the common question of why objects are a certain color, describes the effect photoreceptors have on our perception of color, and reviews the function of pigments. Before beginning, it is important that we review the electromagnetic spectrum, the particle absorption and reflection of different wavelengths of light, and photoreceptors. The electromagnetic spectrum includes all forms of electromagnetic radiation, including visible light. Color is mainly determined by the wavelength of light, and each is associated with a photon with a distinct amount of energy. The longest wavelength appears red, and the shortest appears violet. The full spectrum of visible light can be achieved by using a glass prism in sunlight. Light slows down as it passes through the glass at an angle, creating the separation of visible light, which causes light to split up and spread out, creating a rainbow. Again, sunlight is made up of all the different wavelengths of visible light. Longer wavelengths, such as red, bend less due to a smaller change in speed compared to shorter wavelengths which refract more upon entering the glass prism. For example, violet light gets slowed down more than red light, causing it to bend and split differently along with the remaining wavelengths bending at varying angles, creating the spread out effect. When the wavelengths exit the prism, they spread out even more, returning to its original speed in the air. Opaque object particles absorb and reflect different wavelengths of light. The wavelength that is reflected determines the color of an object. For example, an apple reflects red wavelengths and absorbs all remaining ones, resulting in the apple being red. The retina in the human eye contains photoreceptors that determine our perception of color. Cones and rods are the two types of photoreceptors. Cones determine color vision, and rods assist with low light vision. There are three types of cones that respond to different wavelengths of light: red, green, and blue, each stimulated by different wavelengths. Now we can begin answering why skies are blue. Sky is blue as a result of the different wavelengths in sunlight, the scattering of wavelengths by the atmosphere's molecules, and photoreceptors. Rayleigh scattering is the scattering of electromagnetic radiation such as light with very small wavelengths. Sunlight is scattered by particles in the atmosphere such as oxygen, nitrogen, and so on. Shorter wavelengths such as blue light are scattered more easily, which is why the sky appears blue. Since the shortest wavelength of visible light is violet, the sky should technically be violet, although there is not enough violet light to overcome the strong blue signals detected by our blue photoreceptors. Now on to the second question of why clouds are white. Sunlight is a source of visible light which is part of the electromagnetic spectrum, which can create a rainbow, which is the full spectrum of visible light spread out. When all the colors are combined, it creates white. Water droplets in clouds are larger than the smaller particles in the atmosphere, causing the scattering of light to be different. The water droplets in clouds scatter the wavelengths equally in all directions, and the millions of droplets in a cloud causes the scattered light to interact and mix into a white color, resulting in the white color of clouds. And finally, why is grass green? As sunlight strikes the grass's surface, it reflects green light and absorbs most of the remaining wavelengths. Let's dive deeper and analyze a plant cell, which is also found in grass, more closely. Inside of the chloroplast, there are photosystems which help with photosynthesis, but they also contain chlorophyll pigments which absorb the photons of light. Chlorophyll is important because it is the molecule that does the actual reflecting of green light and absorption of the remaining wavelengths, giving grass its green color. Thank you for watching, and feel free to visit us at www.daniyerinstitute.com.